You can look at any piece of machinery or any technology as being made up of a sensor and an actuator. A sensor is something that detects input coming from the user. An actuator actuates the action that the user intends and manifests it and makes it happen or renders it, produces an output. Let's take a simple example. You walk into a dark room and there's a switch, you flip the switch on, and then a bulb in the ceiling turns on. So the switch is acting as a sensor. It senses the mechanical movement of your hand up or down, and the bulb is actuating it by turning the light on or by turning light. Think deeply a little bit about almost everything around us that engineers have made to make our life better, and you can sort of see that the part of it is a sensor and part of it is an actuator. Another example, the brake pedal in your car. You use it to decelerate. So where's the sensor here? The pedal itself is a mechanical sensor that senses the movement of your foot, and somehow there's an actuator in the wheels, let's say disc brake in the rear wheels, and when you hit the brake, the actuator acts on the wheels and the vehicle decelerates. So we have always these sensors and actuators. For, I would say, 99% of everything you see around you, the connection between the sensor and the actuator is direct. So in the case of the switch that we talked about, how is the switch in the wall connected to the bulb? Well, there must be some wire embedded behind the drywall connecting the two. That's an electrical connection. How is the brake pedal connected to the wheels in the back? Well, there's a hydraulic line. It's a mechanical connection. When you depress this, physically the fluid inside the brake fluid moves, and so we have this connection. Sometimes it's an electromagnetic connection, but one way or the other, it's direct. You do this in the sensor and the actuator does that. If you repeat the action and the machine is working fine, the same action will happen. So what's characteristic about direct connections is that similar inputs produce similar outputs. It doesn't matter at what time you do it, it doesn't matter who is doing it, the action is always the same. In the past few years, however, people started looking at something far more interesting, and that is to have a piece of software mediate the connection between the two. So the sensor senses the action of the human and sends it to a piece of software running some logic, some code. And that code culminates at the end in sending some signal to the actuator. Why is putting the software in between the two helpful? Well, software has two very interesting characteristics. The first is that you can do inside it anything you want, literally anything. The logic that you do that detects, let's say, the flipping of a switch can say, wait a minute, what time of the day it is, and based on that time of day, a different kind of bulb or a different dimming of the light intensity would happen. It can ask who is turning the light on. It can ask, well, have we done this before earlier today? So because of this extreme power that can be done by software, you get enormous versatility in the kind of action that you take. Furthermore, software has state that it keeps inside it. So its action is not dictated only by its input, but also by the memory that it has inside. This memory could be a piece of memory inside it, could be the Ethernet, it could connect with some other thing on the internet, grab some information that's in their memory and act accordingly. So the action, the same action does not always produce the same actuation. All right, so because of this, you open up a brand new dimension in control, and in general, in making life better for a human, because that's the purpose of technology after all. And it can be a lot better if you have software mediating the two. But the introduction of software between the two creates a problem, and that problem has to do with translation. Sensors and actuator both speak more or less the same language. It's a language of voltages, currents, magnets, electromagnetic fields, and so on. But software speaks a different kind of language, and we need a translation between the two. Luckily, the software can communicate with the outside world through ports, be it network ports, be it serial ports, and so on. One of the ports we'll be concentrating on is the universal serial port, USB. All right? So what we really need is for a device to translate the signal coming from the sensor into USB so that the software can read it, acts on it, and then finally, when it wants to produce some output, it will send it to the USB port, which will also need to be translated to the language of actuation, to the actuator, to the motor, to the LED, to whatever is at the other end. Our board, the interfacing board, does exactly that. It translates back and forth between USB and electromagnetic signals.